All right. So, first remote conference that I've ever been to, first one that I've heard of so far that all of the speakers are remote too. So like they were saying, we have a Slack channel, hardware-IoT, throw questions in there. I won't be keeping an eye on it, but I'll definitely look at the questions after, see if I can answer questions in there. And when I unpresent the keynote, I should be able to see any chat that has happened in the actual Zoom. So with that started, since I can't poll the room, I'm going to assume everyone loves security. Also, I'm going to make an assumption that everyone knows and believes that they are part of the security team. Yeah, I'm hearing complete agreement. I like it. And in advance, thanks for coming to my TED Talk. So let's go. I'm David Poindexter, AKA Robert Tables on Twitch. So I am an AWS technical architect at CleanSlate. I've been here for 2 years. I primarily focus on AWS, Terraform, Docker, Node, serverless. I lead a team of experts that can certainly help you. As you can see at the bottom of this slide, my company overall does lots of things with lots of clouds, but that's kind of my focus. On the hardware and IoT side, I took a personal interest in it about a year ago on my Twitch stream, where I would build hardware projects, I would solder keyboards, we would build IoT solutions. I started off kind of with an Arduino, and I kind of progressed from there. Before joining CleanSlate, I had about 12 years of custom application development experience. So about that app dev thing, event-driven architectures in application design are not a new concept, but they are allowing us to build modern, cloud-native, cheap, secure, scalable, and resilient solutions in the cloud. But that's for app dev. What could this mean for security? We're talking about trying to get the right information to the right people at the right time. So what's the right information? Let's consider this. In your cloud, whether you're brand new, just moving into it, been there for a while, it doesn't really even matter which cloud. You've got all sorts of signals coming around. You've got data and logs and alerts and alarms coming from services and events. You have changes from the applications themselves. You've got users, developers, administrators. You've got operations sometimes making some tweaks. Of course, you've also got external events. Things do break all the time, and sometimes it's not your stuff that breaks, it's the stuff you're relying on, like a whole availability zone. Then we're going to start talking about like the right people. Who are the right people? This gives you some examples of these are not the right people for that job. So consider this. Does this group have the permissions to even fix this issue? Can they fix it in this environment, or do they only have access to dev and test? Can they access this environment due to the data classifications that you've put in place? Also, does the person have the right skills? I'm just double checking that nothing is breaking. Does this person have the right skills to be able to fix the issue? For example, if your infrastructure is code, you probably should know how to code. If your issue is billing, does this person even have the concept of what expensive means in terms of your cloud? And then it's about the appropriate action the person would be wanting to take. Are they the right person for the job? Does it make sense for them to fix the issue? Should a developer be taking action on a systemic issue? Should ops be changing root account security questions? I would argue probably not if you've divided responsibilities correctly. So we've got the right information, we've focused it to the right people, and now we're going to talk about at the right time. Not everything is a fire alarm. If everything was high priority, nothing would be high priority. What deserves the focus? And you can't do everything all the time. Also, consider this, that sometimes protocols are breached on purpose. We'll get to that. So about this session, we're going to take a look at kind of the current state, how things are now, how they should be now, kind of the goal you first get into the cloud, or you actually want to like, make this a real thing. What should you kind of have set up? Then we're going to start some user experience discovery. We're going to start focusing on the users themselves instead of the systems. We're going to map those user needs to something a little novel, something a little experimental, a little different. And then we're going to cover some accessible IoT solutions and talk about maybe and then what. So on the current state, these are going to be some common starting points, kind of a model of a journey that I often see with clients. It's not prescriptive, but this is good enough for our purposes for the talk today. In the beginning, there's no data, there's no insight, there's very little transparency by default. So you have a bunch of stuff happening, but you don't know what. And then you want to set up some basic insights into that data. You've got CloudTrail, CloudWatch logs, maybe some alarms on those kinds of things. These things can be aggregated into dashboards. Logs can be filtered, alarms set for CPU and disk and network. But then what? You get a big dashboard full of stuff, right? So this is where we're maybe going to be taking some next steps. Let's start talking about the event sources. So we'll stick to the AWS native event sources, although application code can generate their own events. We're not going to focus primarily on that. So here, we're going to enable detailed monitoring on our workloads, like EC2 and RDS. So this is going to let us see what might be happening inside of our application black box. You can look at, like I said, CPU, disk, network I/O. Things happen, things get hung, restarts are needed. Maybe an incident for availability gets open for the dev team to go take a look at. Some other event sources that you've got CloudTrail that's logging every API call. Anything that anyone is doing in and for your cloud is getting logged. You want to know like who's logging into what and who's creating and destroying things. How did a privilege escalation happen? Why the heck do I have activity in Sao Paulo? We only operate in Virginia. Those sorts of things. Other events here could be native events coming straight from CloudWatch themselves. There's a large number of services that are tightly integrated with CloudWatch events. We're not going to list them all because, frankly, they just wouldn't fit on the slide. But for example, AWS config, guard duty findings, all of those kinds of things. These can be sent to a few different destinations. A lot of people will send them off to SNS and then maybe forward an email on to some inbox for who knows, someone needs to know. Another option might be Lambda. We'll talk more about that later. Then you've also got Event Bridge, which is a relatively new feature from AWS, was released as a managed event bus. And then, like I said, you've also got your EC2 instances where the application code themselves can generate these events that can, again, be forwarded into CloudWatch, that can be logged, they can send SNS topic a message and send that to wherever. Okay. So now these dashboards, okay? We've got these dashboards set up. We got somebody logging on. They're going to a destination to go see the stuff. We need to see all of it somewhere. And building customized dashboards is kind of an industry unto itself. And there's a lot of companies that do this really well, like New Relic, like Splunk. We're not going to be covering those. We're going to keep this relatively native for this talk. It doesn't mean that you have to stay native. We'll see a little more of that later. So here's some examples of some dashboards. We've got AWS config rules. These are showing whether your particular settings are in or out of compliance. We've also got CloudWatch alarms. Again, another dashboard where you have these metrics that are measuring CPU usage. You've got a whole list of things that you can tie to it. You can see when an alarm doesn't have sufficient data to even report. But again, it's a dedicated dashboard. Guard duty itself also has a dedicated dashboard. So now it's like you're going to 3 different places to see stuff that you probably do care about. At least it's all together in one dashboard for the service, right? And then, you know, there's third-party services that have fantastic dashboards. They're very customizable. There's a lot of noise going into all these, though. And think, for example, what if somebody leaves their logging level on as verbose? Is that really a fire hose that you really want to sift through? So yeah, that covers dashboards. So security incident response, a lot of times that I'll see, you know, that destination of where stuff will go is probably going to end up being an email, right? It's some sort of a distribution list. You're going to set up your users, your groups, and your AD, or maybe you're using G Suite. You're going to make sure the right people have the right roles to get the right messages in that distribution list. Mostly SNS is used to push out that email. It's another small step, but now we've got stuff kind of going from the centralized login to it dashboard, at least out a little further to the edge of a system, closer to the users. And nothing that we talk about today is going to replace this. We're just going to kind of add on. So now we're sending things to teams. Perhaps we're noticing that not very many people check these emails. Perhaps there's just a lot of noise and it's hard to find stuff. Even though we're trying to filter it down, maybe there's just a lot of stuff. Maybe we're directing things to the wrong teams. This is where accidents happen, and that way lies madness if you don't have something else. So we're going to now kind of rethink how we can handle a couple of key incidents and security incidents and do it from a user perspective. So we're going to think about these teams. I'm going to focus on just 3 personas today. They're very common personas in your organization. They may have different titles. They may be entire teams. It may be 1 or 2 people, but it's generally the role the person is filling is a pretty common one. Okay, so we've got our cloud. There's a bunch of activity going on in there, and some of it's extremely critical to know about and record for auditing purposes. The auditor probably would be upset, but not totally crazy when something does happen. However, their question is always going to be, what did you know? When did you know it? And what did you do about it? Let's meet Alice. Alice is our Director of Cloud Operations. She kind of manages the meta about our AWS account. The billing, she manages the organization's contact information, those higher level type things that are kind of around the root user account. So we sat down with Alice to learn a little more about how they work, where do they work, what are the tools that they use, day to day, what are you doing, and more importantly, what keeps you up at night. So Alice is telling us about this root user. Now keep in mind, it's a very special user. Naming things is hard, as we heard in the previous talk. The root user is not an IAM user or a federated identity. It's not a human or a service that really should be logging in doing anything. We've got everything set up right. We've got multiple people who could access the root account for redundancy. We got rid of the API keys. We set up a break glass hardware multi-factor device that's locked away in a safe. It should not be used, but let's presume now it's happened. If somebody does this, it's truly break glass. It can happen. Sometimes you have to do it. There are certain actions that do require the root user themselves to do it. So it's going to happen. But if it happens and you don't know about it, that's kind of a big deal. And it's a take immediate action type thing. Your account really can be taken over if someone gets access to that root account. All right. So it happens. We've got CloudTrail set up right. We've encrypted the logs in from CloudTrail in CloudWatch logs. We've got log file validation for integrity. We will know if someone tries to alter history. We've set up a log filter and alarm looking specifically for anyone using that root user to do a login call. And as we've done before, we'll toss this on an SNS topic and we'll make sure that we send it to operations. But now we're going to send it also directly to Alice, our Director of Cloud Operations. This gets it even closer to the right person, closer to the right time. I personally think we can do better. Don't worry, we'll enhance this. Okay, so on this incident response, we've got the powerhouse of our operation, the dev teams. They're the ones shipping the feature. This is where the magic starts to happen, and as a dev, it's near and dear to my heart. Let's meet Tanya. Tanya is the technical lead for one of our dev teams. We start talking about what kinds of concerns they have, how they work, what does their team prefer, what tools do they use, how do they work, what are the unique things that Tanya is concerned about, and unique challenges that specifically take her involvement to fix when things go wrong. So she told us about something that goes wrong. There's a CI/CD server. It's a primary controller, and it's got a set of secondaries that can scale, but it's kind of finicky at times. I'm going to pretend everyone in the audience is nodding their head about finicky CI/CD servers that kind of has issues, and you've got to kick the box sometimes. Well, as the jobs stack up during the normal workday, scaling operations happen. It's usually pretty controlled, even pre-scaled in the morning sometimes, anticipating demand. But occasionally, the primary controller itself gets overwhelmed when that happens, and typically you have to go, as we say, kick the box. A reset operation is needed, and Tanya is the one that does that. So after some time, she'll be able to, her team will notice this. They'll directly message her on Slack. They'll jump in, they'll fix the thing and reboot the box, based on if they think that it's necessary. However, if you'll note, this would disrupt the pipeline progression for jobs already in flight waiting on the queue. And while this is happening, until the reset is complete, no new code can go out. No new code like your infrastructure as code or your configuration as code. It kind of leaves the business and operations in an unnecessarily vulnerable state. So what we're going to do, we've kind of got basic monitoring set up on all of our EC2 instances, but we're going to specifically focus on this critical one, and we're going to set up detailed monitoring. We're going to figure out what is a period of CPU high usage and duration that kind of signals, hey, an incident's coming. Pardon me, I'm going to move my camera out of the way. Okay. So we're going to kind of do the same thing. We'll set up the alert. We're going to treat this as an incident. We're going to preemptively try to jump in and fix this. We'll not only send this to the team's SNS distribution list, we're going to send this specifically to Tanya as well. You're noticing a common pattern. Now we've got it a little closer to the edge, could go to their backup in case of PTO. Again, I think that we can do better, and we'll look at this one shortly too. Okay, meet Steve. So Steve is our CISO, our Chief Information Security Officer. We sit down with Steve. They reluctantly share a little bit of information about their role and their concerns. Only just enough information, if you know any SecOps people. So what about the stuff that goes on inside that wall of trust? So we could set up our security groups and all of that kind of stuff. We've got our defense in depth. But now we're kind of thinking, well, yeah, but say that somebody did break that. Say that we've got the perimeter secured pretty well, but it's like, oh yeah, we have that new VPN connection that does allow us to get into private subnets. Just pretend, what if it did happen? So we're going to reach for a tool from AWS called GuardDuty. GuardDuty uses information pulled from threat intelligence collected all over the world. These are attacks that are happening to AWS themselves that they then learn and add into their models to provide protection and alerting to you. So it uses machine learning to intelligently make decisions based on a baseline of what appears to be normal versus abnormal activity, and then it reports its finding to its dashboard. So the importance of monitoring for certain types of behavior can't be overstated. Privilege escalation by using an EC2 instance role can lead to all kinds of reconnaissance about your cloud, and it can be the start of data exfiltration. That actually happened to a certain very, very large bank and their tragic S3 data. Okay, so we'll again reach for our trusty SNS topic, send the findings to a list. There's kind of a 5-minute granularity to this. I wish it was less, but that's kind of a limitation of GuardDuty. We're also going to send an email directly to our CISO. I don't think that they're going to be sitting around smashing refresh on their email all day, so I still think we can do better, but it's one step closer. All right. So now we've learned about our users. We've managed to further carve out the knowledge from the raw data. Again, we've got 3 use cases that we can actually focus on. We're starting to direct that right information now to the right users at almost the right time. Let's talk through solutioning out some more interesting alternatives. Let's go back to Alice. So far, we're doing pretty good here. There's a clear trail of information that things happened. If the root user gets used for a thing, they'll know, they'll get an email. It's protected, and we can at least make the case that we've thought about this problem, and we have a way to notify someone who then can do something about it. So we've got this SNS topic set up to dual notify a list and our director. Let's also set up a CloudWatch event subscriber. So the source of the message from the event contains a bunch of data. I'm just showing you a little bit here so you can get a sense of all the neat things that you could pull out of these types of messages. But this time we're not sending an email. We're going to use Lambda as the topic subscriber instead of someone's email address. I'm a Node person. I love Node. We're going to use that as the example. And being that this is just JavaScript, we can do whatever we want with this. Let's deliver this right to our director's cell phone via SMS. Here, we're going to use the Twilio SDK Twilio is a communications company, and SMS messaging was one of their very first offerings. It's well supported, easy to use, as you can see in the code. So we're going to execute an API call with the Lambda. The API call needs some basic information, Twilio secrets, phone numbers, things like that. We're storing those as environment variables for the Lambda, as you should. And it'll happily forward it along. The API in Twilio will in turn send this as an SMS message to our director. That is way better, in my opinion. Say, I told you, I thought we could do better. So we did better. Our director is very pleased at this. Timely delivery, being that it's just Node and an SDK, we could send this to multiple people if we want. And also that activity is logged and auditable via CloudTrail and our Lambda CloudWatch logs. Cool. Back to our dev team. So we isolated some of the signal from the noise, as we did before. We're acting in a less shotgun way. The CI/CD servers, they still have issues. They'll always have issues, but at least we minimized the manual detection time and the notification to go fix a thing. So we tailor a notification directly to one of two people that could actually start fixing it. That means we don't have to wait on the dev team to find out there's a problem. Yeah, and as a reminder, ask any questions in the Slack or in this chat that I can't see. I will be able to get to them. So we got this alarm going off for high CPU usage. We get this incoming CloudWatch alarm sending an SNS topic to a couple of subscribers, namely the list and Tanya. So let's set up another topic subscriber. But for this SNS subscriber, we're also going to use Lambda. And again, it's just JavaScript. We're going to use a basic webhook with Slack. We're going to send this alert on into the dev team's shared chat room directly. Being that it's Slack, this also means that it could be delivered to not just their computers, but it could also be delivered to via the web or on their mobile. To note, due to how alarms work, there's a little bit of granularity to that as well. Detailed monitoring, it can't be down to the second. But we now have gotten to the point where this is a truly push notification. So it's the right information, it's going to the right people, and this is way more the right time. So here's what it looks like. Slack has lots of different ways you can format and design your message. I kept it very basic for this, but this is kind of what you could see. Hey, threshold cross data point, sends it right into the Slack chat room. So you can see with just a little bit of discovery with our users, we determine a way to get this right information to them, not only at the right time, but with the tool that they told us that they use every day. And it's not limited to Slack. It's a basic webhook and Node. This could go to Amazon Chime. This could go to Microsoft Teams. This could go to Slack. Anything that supports a webhook, you could see we've introduced precisely zero magic to any of this. Now for our CISO. We've already seen SMS notifications, and we've seen Slack notifications. So here's two other non-AWS integration companies that we've been able to use. But here's some really cool stuff. So with IoT, we can use some pretty easy to use devices, and we can really make them do anything that we want. And I'm going to show you what I want it to do. So we've got our source of event, same thing. We've got SNS set up for a guard duty finding gets triggered. We're again going to add Lambda as a topic subscriber. It's just Node, and it's just a JSON event coming in. But we'll do something a little different, and we're going to reach for a service called Particle. Particle is an IoT and cloud company. They have devices, they have device management. They also have what they call their cloud, and I'll talk about that here in just one second. So we're using Particle's Node SDK to call a cloud function. This is just a function that's defined and executed in Particle's cloud via an API. We're going to send this function a parameter, say an integer or high or defecation has sent the ventilation or whatever you want to send it. But this basically means like, whoa. And so what happens is when we call this function, it reaches out to a connected device. So the device I'm going to use is a Particle Boron. It's connected via onboard LTE to the Particle cloud, and it's also running the code on the board that defined the function in the cloud in the first place. The functions are per device, and so that's why you'll still need the Lambda if you were confused. Wait, Particle has functions, AWS has functions. And so our device gets called with this parameter, we can react to it. How do we react? Our Particle device, you could see there on the left, our Particle Boron, we're going to Receive that function is called, and then we're going to send a very basic serial message over to another locally connected device in a TX-RX serial 2-wire setup. That device is the Adafruit Circuit Playground Express. If you have not gotten one of these, they're fantastic. So the device is going to respond. It's Python code. I'm not the best Python writer in the world, but bear with me. This will now activate a predetermined pattern on the embedded array of RGB neopixels. It could even play a sound if we wanted, maybe the red alert sound from Star Trek, if you're kind of a fan of that franchise. So our CISO loves this. He's got a special little spot right on his desk for it. He thinks it's the most inventive thing in the world. He doesn't even have to have internet connectivity because it's LTE. We could power this all with lithium-ion batteries. This is really beyond on-call. So let's get into this solution. A little deeper dive. All the code will be on GitHub. Trust me, it's not the greatest code in the world, but it works. And the rule is make it work, make it good, and if you need to, make it fast. So here's a little close-up of our device. Kind of a cool little thing, isn't it? So particle boron, like I said, you can power it via USB, as I had in the previous picture, or through lithium-ion 3.3 volt battery. They're very, very common. The pinout is feather compliant, featherwing compliant, and it costs $53. Now, if you're going to be getting a lot of these kind of things, of course, it would make sense to not get the dev board, which is, you know, the most expensive variant of the thing, but you kind of get an idea. So our cost, okay, $53. All right. So keep in mind the numbers that are adding up here. Throw in maybe a couple of bucks for the miscellaneous wires and jumpers, and the breadboard, and that's probably going to come around to maybe, let's say, $65. So here's what that code looks like. These run pretty much like any other embedded device you would be used to, where there's a setup function, initialize things, and then there's a loop. So here's what the setup has. We say particle function and pass it the name of the function that particle cloud will know it as. And the second parameter is the function we will actually implement. Here, I initialize the LED to output just so we could see it blinking to know that it's kind of on and doing its thing. We open up the serial, we wait for a serial connection, and I have to include printout hello world here. So then this is the function implementation. So we're just declaring an alert interval of 0, 1, or 2. When we get called with that, this function execute, it gets the level that's passed to us. We're just going to do a basic switch on that number, and we're going to then set that variable. Again, this is all outside of the loop. In the loop, we're just constantly switching on that, and we're just going to be sending out to serial over that TX-RX connection. What is our current condition? Is it, is it high? Is it low? Is it neutral? Reset the whole thing. And that's all going to, this is the Adafruit Circuit Playground Express. It's got a bunch of onboard sensors. It's got capacitive pads all around the edge. That's also the pinout. It costs about $25, so we're still around less than $100 for this entire solution. It's got onboard LEDs that are individually addressable RGB. So you can do patterns, you can do flashing effects, you can do rainbow changes. You could do anything that you want. In this case, we had just had it go red, be scary. The unique thing about this is it's not really a write and compile type thing like the particle series are. This, you just write Python. It's running its own software where you drop the Python code in a disk that mounts to your machine when you plug this in, and it will pick up any changes and automatically reinterpret just the Python code. You don't have to flash this device or compile anything. There's lots of examples. This is a great way to get kids into IoT. The particular one I'm showing does have Bluetooth Low Energy, so you could do a device mesh, but it has no network though. There's no network on board, and that's kind of why I paired that up with that particle device. So here's a little zoom in on what that code looks like. Again, all of this code is up on GitHub. This is kind of what this looks like. It's in the while loop. And while we're getting data off the serial, we're just going to split on that, and we're going to just do the most naive check ever, where we're saying, do we get this? And we're just going to set a variable for the active color, and then we're going to fill the pixels with the active color, and then we're going to show the pixels with the light on every loop in the while loop. That's kind of what it looks like when stuff is malicious activity is detected. There is a library that you can actually simulate these kinds of attacks. Hang on. Okay. They wanted to shut off because there's no sound coming through here. You can actually use CloudFormation to build out this entire, multi-EC2 instance, and there's a script that you can run. This is all from AWS that will try to do malicious activity on an instance, attacking other instances and DNS port scanning and DNS exfiltration, so that you can actually trigger real events. You can also simply just go in and press the sample events in the GuardDuty console. So you'll be able to test, is this thing going end to end? So the Lambda gets fired, particle cloud function is called by the Lambda, particle cloud sends that down to the local device, the local device sends a serial message over to the Python device, and the device responds with lights. Then if you go neutralize the GuardDuty active finding, then it's going to also trigger the Lambda that, hey, this was neutralized. It's going to send another message through the cloud, down to the device, over to the Python device, and kind of reset the lights. I think it's pretty cool. Under $100 for this kind of a layout. I was wanting to maybe miniaturize this, make it more transportable, and then, this happened. And so there wasn't exactly a need for that. I transported it exactly 2 feet from my hardware bench over to here. So on that note, the end goal of what we were really doing with each of these 3 exercises, we thought about the normal cloud maturity progression of gaining insight into what the heck is going on. We saw some native tools. Some of the tools might be new to you. Some of them may not be. We explored some user needs from their perspective. We mapped out what would be the right information for these right people. And we kind of looked at how could we get things a little closer to them, a little faster to them. And now we can kind of get some ideas on, are there ways we can enhance this? So this isn't a technology problem so much as it's a human, teams, and organization problem. The cloud has all of the tools. We have the creative ideas to be able to use them. We understand that we have heuristics for a reason. Why are particular events more important than others? Nothing in this talk is going to replace any of your tools. We're not trying to say that you shouldn't use vendor products, PagerDuty, New Relic, Splunk, and the like. The cloud is about leveraging lots of tools in the right way in concert. So when you've got all of this data flowing in and around your cloud, drinking from the fire hose is fine for your first week on the job. It's not exactly what your security operations should feel like. You're finding the signal in the noise so that you don't miss the important stuff. And we want to get this stuff to people. People do want to help. We have to know what's going on, but not every single data point matters. Who is making these directional calls? Is this a top-down thing, or are we talking to our teams? Are we listening to our teams? Are we asking them, how can we help you be better? All you have to do is ask. So, we're nearing the end of the talk, and I want to talk about next actions. I want to talk about what I want you to do today. Step 1, hop in the Sponsor Clean Slate Slack channel. I'll be hanging around in there all day today, all day tomorrow to answer questions. I can share anything that I have. I'll be updating the repo with these slides. I'll provide data sheets for exactly where you want to go to buy these things, exact breakdown of cost of what you can expect to spend. So stay curious. The next one is go check out the code. Go to that GitHub. Again, I'll be dropping all of those links in our Clean Slate channel here at the conference. I want you to try out the code. You can use the device simulator in VS Code to run the Python code with a simulated device before you even buy one. So do go play around with that. Then the next thing that I want you to do, I want you to go get the devices. I want you to play around. I want you to connect some alerts from your cloud into these devices. Play around with it. Let me know what you come up with. Reach out to me after you've impressed your coworkers and show me the proof of concept. And then, of course, reach out to us if you need any help. On that, because you are all so nice in braving this new pathway on this remote conference, I want to let you know that as a special thank you, we have offers for every attendee. The first one is a cloud cost optimization because everyone wants to save money. I can help you directly with that. Reach out to my folks in the Clean Slate channel. Then we also have a planning workshop, a strategy to get the most of your cloud investment, whether you're starting from scratch going into the cloud or you want to further refine and mature your cloud. We can help you with that too. Just hop on into our room. And with that, thank you everyone for coming. That is the end of my talk.